Lesson 6.1 on the values of basic trig functions. So we are beginning the unit of trig on this now second semester of pre-calculus. And here are a couple of bullet points, just kind of summarizing the direction we are going in. Trigonometry is one of the most powerful and useful branches of mathematics, and it's applicable in science. Trig is based on angles, distances, and triangles, specifically the relationship between an interior angle in a triangle and the ratio of its side lengths. Pythagorean theorem. It allows us to find the length of any side of a right triangle if we already know the other two sides. Trig is a more powerful tool because it allows us to find one side of a triangle based on a reference angle and a corresponding side. Trig also allows us to find an interior angle based on two sides of the triangle. Despite the diversity of the applications of trig functions, the entire subject can be boiled down to three basic trig functions and their reciprocals. So I know that's a lot of information that I just read, but I just wanted to show you just the different approaches that you will be tackling as we move forward. So let's go ahead and go back and review a couple of things that you probably have not seen in a while. Okay, so let's look at right triangles. For a right triangle, angle triangle, the relationship between the length of sides and angles is described using trig ratios. You would have covered this in geometry, but just in case it's quite not fresh in your mind, we are going to do some reviewing. So the three primary trig ratios are sine, which we're going to use the letters sin, cosine, cos, and tangent, tan. So what I've highlighted in light blue are the abbreviations, okay? So the trig ratio sine will always be opposite over hypotenuse. So what you're going to notice is that when you take the sine, you are going to have to specify an angle where you are standing. Specifically in this particular problem, we are saying the sine of angle A. So that just means that you have to picture yourself as standing on that corner right there. So just picture yourself standing here, and based on your point of reference, which is angle A, your opposite would be the side directly across from angle A. Your adjacent side would be the side right next to you, and your hypotenuse is always going to be the longest side, and notice that it is always directly across from the 90-degree angle. Okay, so you always have three sides, and those three sides are going to be considered either the opposite, adjacent, or hypotenuse based from where you are standing. Okay, so just to give you another perspective, I'm going to use a blue instead. If I'm standing here at angle B, right, my opposite side is going to be this one, the side directly across from it. That would be opposite in this case, right? And then my adjacent side would be this one right here, adjacent, and my hypotenuse is that one right there because it's across from the 90-degree angle. So what I always tell students, truthfully, is always find the hypotenuse first, and then the other two angles, you know, have to be, not angles, I apologize, the other two sides have to be either opposite or adjacent, okay? So make sure you practice identifying those. Another thing to notice that your opposite side and your adjacent side are always going to be the sides that form the 90-degree angle. They will always be the ones that form the 90-degree angle. All right? Okay, but for this particular problem, please notice that we are standing at angle A. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So yes, there is an acronym, SOHCAHTOA, that a lot of students use to help them remember. And the most popular one is, I think it's some old horse. No, there's so many, by the way. Some old horse caught another horse. What is it? Some old horse caught another horse taking. That's what it was. It's like taking oats away. And so if you notice the beginning letters, if you remember that phrase, the S, the O, the H, C, A, H, T, O, A. So there's your acronym. Okay. So it helps you memorize your ratios. So moving forward, I just go over here at the end of your first page what opposite, hypotenuse, and adjacent is, which is what I've already discussed with you. So now let's go over here to the next side. Now, in addition to those first three, we also have what we call the reciprocal trig ratios. And these, yes, are going to be new ones to you. If I'm not mistaken, those are not covered in geometry, and I do not think you guys cover these in Algebra 2. But here goes. There's the reciprocal trig identities are going to be the cosecant, which is abbreviated CSC, secant, which is SEC, and cotangent, COT. So reciprocal means you are going to take the original ratios and you are going to flip them, okay? So what I want you to notice here is that cosecant is the reciprocal of sine, and I'm going to use A, keep the same angle. Secant is the reciprocal of cosine of angle A, and cotangent, which is the closest in name, is the reciprocal of tangent of A. So you will notice that they are just flip of one another. So I'm going to do this right here so you'll see what I mean. Notice that sine is O over H, right? The reciprocal of sine would be H over O, which in this case here is H over O, okay? And then the same goes with the other two. So remembering which are those reciprocal identities is something you'll need to memorize. One thing I pointed out to students is notice this. This is an S. It starts with an S, so the reciprocal started here with a C. But if this one starts with a C, its reciprocal starts with an S. And tangent and cotangent, well, those are just obvious because they have the letter T in it. You know what I mean? So sine, its reciprocal is cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So if you already know what the other ones, the first three are, you automatically know the next three, okay? So here's what I mean by this as far as if you have a quiz in the future and you tell yourself, okay, I know some old hippie. Oh, this is another one. Some old hippie caught another hippie tripping on acid. No, I'm not proposing anybody do drugs. But here's another acronym of some old horse caught another horse taking oats away. So I know that this is sine, right? So this is my sine, this is my cosine, and this is my tangent. So the reciprocal of sine has to be cosecant, so CSC. The reciprocal of cosine has to start with an S, SEC, and the reciprocal of tangent is cotangent, COT. So I know cosecant has to be not O over H, it's going to be H over O, because instead of it, I guess I should do it this way. I should put so O over H. You can do it like this, A over H. Whoops, There we go. And tangent is O over A. So you can do SOHCAHTOA like that. So this one has to be H over O. This one has to be H over A. And this one has to be A over O. Okay? So those are different ways that you guys can think of remembering. But right now you have your notes, so you can use those as reference tools. Okay? So anyway. So how do we do some practice problems? So these are the type of problems that you guys are going to see in Delta Math. And the first 5 are going to look like this first practice problem. And it's a review of what you guys did in geometry. If you're given a right triangle, now I know this is a right triangle because it has a 90-degree angle. And I am asking you to find the missing side, this side right here. Okay? So I am going to use the Pythagorean theorem that says if I take one of the legs and square it and add it to the square of another leg, it has to equal the hypotenuse squared. Okay? Now, what lots of students remember that is as a squared, it corrected itself. A squared plus B squared equals C squared. But what I just need you to remember that A and B stand for legs. Now, your legs are always going to be the sides that form the right angle. So if this is my right angle right here, my legs have to be the ones that form, that right angle. So this would be a leg and this would be a leg. All right? And the hypotenuse, as we've said before, is always across from the 90-degree angle. So I know that I was given a hypotenuse and I was given a leg, and the leg that I'm missing is what I need to look for. So let's substitute. Leg squared, I'm going to put in parentheses 4 squared plus, I don't know what that leg is, I'm going to use the letter X, squared equals, and hypotenuse is 8 squared. 4 squared is 16. 64 is 8 squared. And now I'm going to solve for X. So I need to subtract 16 on both sides. And I am going to get, let's see, 14 minus 6 is 8. 5 minus 1 is 4. I get 48. Okay, so X squared is equal to 48. Now, I know I need to square root both sides to solve for X. So X is going to equal the square root of 48. That is not a perfect square, okay? So I need to simplify it if I'm able to do so. Now, there are different ways people do it, but the most popular way that students use is the factor tree. So we're going to multiply two numbers that multiply to be 48. I see that this number is an even number, so I'm going to divide it by 2. And I know that if I divide 2 into 48, or 48 divided by 2, it's going to be 24. 2 times 24 gives me 48. Okay. Now, 2 is a prime number, so I'm just going to leave that. I'm not going to touch it. I'm going to circle it because I want to make it a point. I'm done with that number. I need to break up 24 because 24 is not a prime number. I'm going to divide it by 2 again. So 2 times 12. So this is a prime number. I'm not going to touch it, but I now need to break up the 12. So notice that you are factoring all numbers that are not prime. 12 again is an even number. I'm going to divide it by 2. 2 times 6. Don't touch this. To break up the 6. 2 times 3. This is a prime number. 3 is also a prime number. And I stop. Okay? Once you stop, you collect your pairs because it's a square root. So this and this go together. This and this are going to go together. And that 3 has no company. So X equals square root of 48 is going to equal 2, because this becomes a 2. I'm going to put a square. Okay, and this is going to become a 2. All right, and that 3 is all by itself. So 2 times 2 is a 4. And what stays inside is a 3. And you're done. So the answer is X equals, 4 square root of 3. Okay. Now, If this little factor tree is kind of confusing you, another way I show students, whoops, didn't mean to do that, is this way. Once you have circled all those red numbers, right, you can tell yourself, okay, the square root of 48 is the same thing as saying all the numbers that are circled. 2 times 2 times 2 times 2 times 3. This pair go together, they got to leave. This pair go together, and they got to leave, okay? Well, 2 times 2 is 4, and the square root of 4 is a 2. So that when it leaves, it's just a 2. And this 2 times 2 is 4, but the square root of 4, when it leaves, it's a 2. This 3 cannot go anywhere. So these 2 left, so they became a 4 on the outside, but the 3 stayed inside. So that's another way you can do it. There are many different ways, okay? And some students use like the highest perfect square. Like, I'll show this one really quickly. Square root of 48. You find the highest perfect square, which is 16. And 16 times 3, I know, is 48. Well, the square root of 16 is 4. And square root of 3 can't be simplified. So there's your other answer. So different ways for you guys to do it. You find your comfort zone, okay? All right, let's go to the next problem. Here we go. So let's make that a little bigger. All right, so given cosine A is equal to 7 over square root of 85, and that the angle A is in quadrant 1, find the exact value of cotangent A in simplest radical form using a rational denominator. All right, so rational denominator means no square roots in the denominator, okay? No square roots whatsoever. So let me write down here, and you can put it in your notes. No square roots. No decimals, all right? No square roots, no decimals. All you want is rational numbers. Rational numbers are like whole numbers or integers, numbers that can be written as a fraction. Okay, so let's do this. First, let's construct a picture of a right triangle to make us have a visual that makes it easier. Now, they said it's in quadrant 1, so that makes it simple for us, okay? So a quadrant 1, so think about this. If this is your quadrant 1 is somewhere in here. So I'm going to make a right triangle that looks something like that in the first quadrant, okay? So I'm going to erase this here. So quadrant 1. So here is my right triangle, the best I can do. So here's my 90-degree angle. And they're saying cosine of A. So cosine of A has to be one of the acute angles. You can't stand on a 90-degree angle. So I can make A either this one or this one. All right. I'm going to make it this one here at the bottom. Then I'm going to call this one B. I'm going to call this one C, just for labeling's sake. Now, they are telling me that the cosine of angle A is 7 over the square root of 85. Now, if you look at your notes, cosine is the adjacent over the hypotenuse, okay? The adjacent over the hypotenuse. So I'm standing here, and I have to label the A and the H, the adjacent and the hypotenuse. Now I'm going to label hypotenuse first. Hypotenuse is across from 90 degrees. So from here, my H has to be this side right here. Okay? Oh my goodness. Hold on. There we go. My H has to be that side because it's across from 90 degrees. So my A is either going to be here for adjacent or here for adjacent. I know that adjacent means next to where I'm standing. And between those two A's, the one next to has to be the closer one. So that's going to be my adjacent side. This is the adjacent side. and this is the hypotenuse. Okay, so for A, adjacent, they want you to put the number 7. So I'm going to erase adjacent, and I'm going to put the 7 here. And for hypotenuse, they said label it as square root of 85. So square root of 85 is this side. So I want to find cotangent A. So they want us to find the cotangent of angle A. Cotangent, if you look at your formulas, is the reciprocal of tangent. So instead of O over A, it's A over O. Now here's the good thing. A standing for adjacent. I have the adjacent length. I already have 7. Okay, that was given to me. This was adjacent right here. So I'm good. But the opposite side, which is this side, I don't have a number. So I'm still missing a piece. So I need to find that side. So how do I find that side? Well, I'm going to use Pythagorean theorem to find the missing side length so that I'm able to complete the problem. So here we go. Let us do leg squared plus leg squared equals hypotenuse squared. So leg squared, my first leg is remember, legs are the ones that form the 90-degree angle. So this here is a leg and this here is a leg, right? So leg squared, 7 squared plus the other leg, I don't know what it is, so I'm going to call it x squared equals hypotenuse squared, square root of 85 squared. 7 squared is 49 plus x squared, and a square root that is squared just forces the square root to disappear, and it becomes 85. I need to subtract 49 on both sides, and I'm going to get x squared equals 36. I need to square root both sides, and when I do so, that's a perfect square. X is equal to 6. So this opposite side is a length of 6. So now I can see that I can substitute my question mark. So the final answer for this one, I'll put it over here in this corner. The cotangent of A is 7 over 6. And in your delta math, all you do is type 7/6 if I'm not mistaken. Okay? So let's do one more. Make sure that you guys are good to go. Secant A is square root of 13 over 3. Angle A again is being told to be drawn in quadrant 1. Find the exact value of sine A in simplest radical form. All right, so let us draw this triangle again. Make it a right triangle. All right. This is my 90-degree angle. All right. So they gave us secant of angle A is square root of 13 over 3. Secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. This will therefore be hypotenuse. Let me put a different color. Hypotenuse over adjacent. Okay, so that's what these numbers represent: the length of the hypotenuse and the length of the adjacent side. So I need to label where my angle A is going to be. It's either going to be here or here. Okay, so since we did it at the bottom on that one, I'm going to do it at the top on this time up here. So notice that I always circle the angle I'm standing at just to remind me where the angle is. Okay, so if I'm standing there, first of all, they gave me the hypotenuse is square root of 13. So I'm going to come over here and I'm just going to label hypotenuse right off the bat. I'm going to make it, put a little h here to remember that that's my hypotenuse. And let's do this. I'm going to put a square. so it doesn't get mixed up with other stuff, okay? And then my adjacent is a 3, so my adjacent side has to be the side that's next to me. So if I'm standing right here, my adjacent side has to be right here. This is A for adjacent, by the way. Okay, and my adjacent is a length of 3. So this is the part that I don't know, question mark, and it so happens to be that this one too is also missing the length of the opposite side. Okay, so we need to go find, which is the one we're looking for, sine A, sine of angle A. Now, the sine of angle A needs O and it needs A. All right. O we don't have, so that's still a question mark. And A we have, it's a 3. So I need to go find O. So let's do our leg squared plus leg squared equals hypotenuse squared. So my leg are the sides that form with the 90-degree angle. All right, those are my legs. So 3 squared plus the unknown squared equals square root of 13 squared. 9 plus x squared equals 13. I'm going to subtract 9 on both sides. And I'm going to get x squared equals to 4. And when I square root, my x is a 2. Oops, no, I'm not going to circle that. Well, we'll box it in, but that's not really the final answer. So 2 is my opposite side. So I'm not going to box that. It's not that's bothering me. So let me do this correctly. X is 2. I use that information to substitute there. So the sine A, which is what I was tasked in finding, the final answer is 2/3, and you would type 2/3. Thanks for watching, and good luck with the homework.